What's up, everyone? How are you all? Sean with Create Your Lifestyle Academy. And episode 4, this episode, we are going to talk about the history of the atomic theory. And this is a good milestone that we have reached because it really combines the scientific method with the concepts of matter and energy that we discussed in episode 3. And I'll explain how in the conclusion of this video. But for now, I'm going to dive into the history of the atomic theory, and we'll get to eventually towards the end the model of the atom that we know and use today. And so it all starts with a guy named Democritus. And this guy named Democritus had some sort of interaction with a higher power. He had some epiphany. And basically, he said that if he has an object, and he cuts that object in half, and cuts that object in half again, and keeps on cutting that object in half, eventually he's going to get to a point where you can no longer divide that object in half. And so what he called that smallest component of the object atomos, meaning uncuttable. And that's where we get the term atom from. It's the smallest component that an object can be. Or so we thought. We'll get to that later, though. So the thing is about Democritus, he was a Greek philosopher in the 4th or 500 BC, and he couldn't prove with data what he was rationalizing. He only had a thought, and so he wasn't a scientist. And so eventually, in 1808, a guy by the name of John Dalton came along, and he basically came up with the same conclusion that Democritus did, except he was a scientist, and so he had some evidence for what he was thinking, and he came up with two takeaways that we're going to talk about. I'm going to write John Dalton's name on the board. He basically echoed what Democritus was saying. Atoms are indivisible. And two atoms combine to form compounds. Cool. Basically, every time someone does an experiment and communicates the new findings that they get, other scientists do that same experiment. And then other scientists will do even more procedures related to that experiment that they came up with themselves in order to find out new information related to the original experiment. And so it's an iterative process. And then I say this to say because a guy after Dalton by the name of Thomson, J.J. Thomson, comes along, and he discovers particles smaller than atoms. He discovers subatomic particles, and he basically yields a little bit more about the composition of the atom, whereas atoms comprise elements. He said these things comprise atoms. This is what an atom is made of. And he discovered a particle that we know as the electron. And the way he came up with the structure of this thing, he related it to a really popular treat in the country that he's from, the plum pudding. And he basically said that there are negative things called electrons spread out in a big positive ball. So the blue's the positive part, and the green's going to be negative. You see how the green's evenly spread out throughout the positive. He called this the plum pudding model. Once again, a little further down the road, a guy by the name of Rutherford, Ernest Rutherford, comes along. He says, no, this is not correct because I've done some experiment of my own, and there's actually space in the atom. And so the electrons are spread out, yes, but they're not spread out among a big positive charge. As a matter of fact, that positive charge is centralized. And he called that centralized particle, positive charge, that area, he called the area of the centralized positive charge the nucleus. Once again, positive charge centralized above the blue. Negative charge surround the nucleus. If you haven't been paying attention, this is where you want to pay attention, because these last two breakthroughs in relation to the history of the atomic theory are very significant. So a guy by the name of Bohr comes along, and he has this model that basically says electrons move in orbits around the nucleus. They're just not spread around randomly. They move in orbit. Positive charge. And these orbits they make rings, quote unquote, around the nucleus. And just to give you a little context, scientists have been wondering where to find electrons. I mean, it's very interesting that we want to be able to. Scientists have always wanted to know where we can find electrons. You can't know the speed of electron and location of the electron, or vice versa, at the same time. So that's why this is significant. He was like, I've got a general area of where we can find these electrons, right? And so they move around in orbits around the nucleus. And cool, that's great. So just to echo that one more time, he called the area around, called that little circular pattern around which the electrons orbit the nucleus, the positive part of the atom, orbits. And then lastly but not least, you have Schrodinger. Schrodinger, basically one-upped Bohr's model and got a little bit more specific about the area and the behavior of electrons. He proposed and he proved that around the nucleus, green still negative, electrons move in patterns like bees around a hive. And these bees are swarming around the hive, and they do so in general specific areas around the nucleus, and these areas he called orbitals. And so we'll get into orbitals in subsequent videos, but that's basically how Schrodinger was able to get more specific about the electron, the pattern of the movement of the electron, excuse me. So we got the negative right here, and you'll find, and as you watch more tutorials, scientists like to like draw squigglies. This is fun. And so we'll be closing up in a minute, but I just want to say that after Schrodinger, Rutherford discovered the proton, and then Chadwick discovered the neutron, and those are the two components that make up the nucleus, positive charge. The protons are the positive charge, and the neutrons are of neutral charge. They have no charge, and these two particles that are subatomic comprise the nucleus. And in practice, we oscillate between Bohr's model where the electrons circle in orbits, and Schrodinger's model where electrons move in a little pattern around the nucleus. So that's basically a brief summary of the atomic theory. And I want to say that this really illustrates the scientific method in real time, because we see how different experiments were formulated after another to improve the atomic theory model that we adopt contemporarily. And it combines it really combines with the fact that we want to discover more about matter and its behavior, and how that translates to different forms of energy that we can use. So this has been another episode of Beyond the Bonds. Sean Patterson, out. Hit that subscribe button, and like this video, and leave some comments about what I can improve on or what you would like to see. Thanks.